Hi, welcome to DUL-TECH concept. Today we will be calculating the value for this resistor which protects this LED from getting damaged. So what we will be needing for this project is LED, resistor, breadboard, battery, multimeter, and some jumper wires for our connection. Okay, before diving into our connection, we will need to know what input voltage we are dealing with. What is the value of our input voltage? And then we have to know the power rating of this very LED. Okay, here my LED operates on 3.2 volts, which the current of this LED is 0.02 amperes. Now let me use my multimeter to measure the voltage of my input source. Okay, it happens to be 6.48. okay, my input voltage is 6.48 volts. Okay, now we will need what we call the Ohm's law triangle, which V over IR. Okay, now the first thing we need to do is subtract our input voltage, or rather to subtract 3.2 volts. That's to subtract the voltage that this LED operates on from our input voltage. Now using our calculator quickly, we will have 6.48 minus 3.2, which happens to be 3.28 volts. Now using our Ohm's law triangle to calculate for the resistance of this very resistor, we'll see R is equals to V over I. That is, V, if we are calculating for the voltage, you have to multiply these two. If we are calculating for the current, we have to divide voltage by the resistance. But since we are dealing with the resistance, we have to divide voltage by the current. So this is what we have here. And our voltage happens to be 3.28 volts divided by the current, the operating current of this LED, which is 0.02 amperes. So now we have 3.28 divided by 0.02, which happens to be 164 ohms. Now we need 164 ohms to power this LED effectively without getting damaged. Mind you, when we insert 164 ohms here, when we measure the voltage, across this resistor, what we are expecting to read from our multimeter should be 3.28 volts. So we have a voltage drop of 3.28 volts across this resistor. So now the problem we have here is we don't have a 164 ohms resistor. So better still, I went for 220 ohms resistor, which will protect this LED from getting damaged very effectively. We don't have 164 ohms in the market. We only have 100 ohms, 120 ohms, and probably 150 ohms, but we don't have 164 ohms in the market. And what I have with me here is 220 ohms resistor. So we're using this 220 ohms resistor to carry out our project. Okay, now assuming we are using a 9 volt input source, for example 9 volts input source. Now let's use the same steps we use in finding the resistance of this very resistor to find when we are using a 9 volt input. Now our operating voltage and amperes of this very LED is 3.2 volts and 0.02 amperes. So we are operating it on 9 volt. Okay, we are powering this circuit now with a 9 volt DC source. So now we'll say 9 minus 3.2 volt. That's 9 as our input voltage and then 3.2 volt as our operating voltage of the LED. So using our calculator, we have 9 minus 3.2, which happens to be 5.8 volts. So using our Ohm's law triangle, we will have R is equals to V over I, which our V, that's for voltage, is 5.8. That's voltage drop across the resistor. It's 5.8 divided by the operating current of this LED, which is 0.02 amperes. Now dividing 0.02 from this, we'll get 0.02, we'll get 290 ohms resistance. So this is the value of the resistor you should put to protect this LED from getting burnt using a 9 volt DC input.